Think about the distance from your house to the nearest grocery store. Now imagine stretching that exact distance straight down into the dark ocean, with crushing black water pressing against solid rock from every single side. The weight is so intense that it would crush a human body completely flat in a single second without leaving a trace. The darkness down there is total and unbroken. Right now, engineers in China are carving a massive train tunnel through that exact kind of crushing pressure. But here's the part that sounds completely made up. The giant drill doing the work does not just push through soft mud, it is chewing through solid volcanic rock deep below the sea floor, and the train inside will zoom by at 200 miles per hour while fish swim just a few dozen feet of concrete above it. By the time you finish this story, you will understand exactly how they stop the ocean from flooding in, why this specific project changes how the entire world thinks about crossing water, and what it really takes to build a high-speed railway on the bottom of the sea. If stories about massive machines doing impossible things under the dark ocean keep you up at night, tapping the subscribe button and the like button right now guarantees you will never miss the next deep dive when it finally drops. For a very long time, putting a high-speed train underneath the ocean was simply a dream that nobody could make real. The problem is not just about digging a hole in the ground, it is about surviving down there. Water is incredibly heavy. When you go down even 100 feet below the surface, the weight of the ocean pushes against anything you build with the force of 100 cars stacked on a single person. If you try to dig a tunnel through the mud and rock down there, the water finds every tiny crack instantly. It rushes in with terrifying speed. The tunnel floods. People die. Because of this constant deadly threat, countries around the world have mostly stuck to building bridges over the water or digging tunnels under dry land where the ground is dry and safe. Bridges work fine most of the time, but they have a very serious weakness. When a massive storm rolls in from the ocean, or when a huge cargo ship loses its steering and drifts off course, a bridge can be destroyed in minutes. We have seen this happen many times in history. A bridge gets hit by a ship, the road falls into the water, and an entire region is cut off from the rest of the world for months or even years. An undersea tunnel hides below all of that surface chaos. It sits perfectly safe from wayward ships, safe from hurricane winds, and safe from crashing waves. But the trade-off for that safety is that building it means fighting the ocean itself in total darkness. You cannot see what is ahead of you. You can only guess what the rock looks like based on small drill samples taken months before the real digging even starts. So, for decades, the idea of a true high-speed railway crossing deep under the sea stayed locked on paper. Nobody could figure out how to make it real without taking huge, deadly risks. Early attempts in the 1800s to dig under rivers in London almost killed the workers multiple times. The soft ground kept collapsing, and the muddy river water kept pouring into the hole. They eventually finished, but it was a slow, terrifying process that left people bruised and broken. Later, Japan built the Seikon Tunnel under the ocean, which was a massive achievement for its time. But that tunnel was built for slower, heavier freight trains, not lightweight, high-speed passenger trains. The Japanese tunnel also sat deep under the sea floor, but they used older drilling and blasting methods with explosives, which was incredibly slow and dangerous. Blasting rock under the ocean is like hitting a glass fishbowl with a hammer. You hope it holds, but you are never quite sure. Later on, other countries tried different methods. They would dig a huge trench on the bottom of the sea, drop giant steel tubes into the trench, and then cover them back up with mud. This worked for slower trains, but it was not deep enough to avoid ship anchors or huge undersea currents. To run a train at 200 miles per hour, the tunnel has to be perfectly straight and incredibly deep. Modern engineers knew they needed a completely different approach. But what if there was a way to change the rules of the game entirely? To understand how China solved this massive problem, you have to picture something you probably have in your kitchen right now. Think about a metal cookie cutter pressing down into a flat sheet of soft dough. You press down, twist, and lift. The cutter slices a perfect circle, and the dough stays perfectly inside the metal tube as you push it down into the pan. Chinese engineers took that exact same simple idea and built a machine the size of a football field to do it under the ocean. This incredible machine is called a tunnel boring machine. A tunnel boring machine is basically a giant rotating drill that slowly eats through rock and dirt, moving forward like a slow mechanical earthworm. Instead of just making an empty hole in the ground that could collapse at any moment, it slices a perfect circle and immediately lines that circle with thick concrete so the earth and water cannot fall in. Here is how the whole process works, step by step. First, the huge front face of the machine presses against the solid rock wall. It has dozens of metal teeth mounted on it, and these teeth are called disc cutters. Disc cutters are like extremely heavy, sharp steel wheels that roll across the stone and crush it into smaller pieces. As the whole machine slowly pushes forward, these wheels grind the solid volcanic rock into small, loose chunks. Second, those loose rock chunks fall down into a spinning area at the bottom of the machine. This is where the ocean part gets extremely tricky and dangerous. They cannot just leave the crushed rock sitting there, and they definitely cannot let the heavy seawater pour into the empty space. To stop the water, they mix the crushed rock with a special type of thick, gooey liquid. This liquid is usually made of a special type of clay and water mixed together. It acts like a thick, heavy shield inside the hole. It pushes outward against the walls of the tunnel, balancing the heavy pressure of the ocean water so the soft ground does not collapse inward. It is exactly like putting a firm finger over the top of a straw to keep the liquid from spilling out. The outward pressure of the mud holds back the inward pressure of the sea. Third, a massive pumping system sucks this muddy rock mixture up through a long pipe. It shoots all that messy sludge straight up to the surface of the ocean, far away from the digging area. This keeps the space at the front of the machine clean, so the sharp cutting wheels can keep doing their job without getting jammed or stuck. Fourth, and this is the most amazing part of the whole machine, the back half of the tunnel boring machine is actually a moving factory. Huge robotic arms pick up curved pieces of thick concrete that were built on land and shipped to the site. These mechanical arms carefully slot the heavy concrete pieces together like pieces of a rounded puzzle, forming a perfect solid tube. Heavy steel bolts lock the concrete pieces tightly in place. As the giant drill moves forward one single step, a brand new ring of concrete tunnel is completely finished right behind it. The drill never stops moving forward. It eats rock at the front, builds the safe tunnel at the back, and the workers inside just follow along inside a finished, dry, safe concrete tube. Keeping the air breathable inside this giant moving machine is also a massive challenge. The rock deep underground can release poisonous gases, and the engines give off exhaust. To fix this, massive fans blow fresh, cooled air through giant tubes that stretch all the way from the surface to the digging head. Without these fans, the workers would suffocate in minutes. The air inside is actually cleaner than the air in some big cities above ground. Getting the workers and the equipment in and out of this moving factory is also a complicated trick. Because the front of the machine is filled with that high-pressure mud shield to keep the ocean out, you cannot just open a door. The workers have to walk through a small steel room called an airlock. An airlock is a small chamber with two doors where you change the air pressure slowly so your body does not get hurt. When that messy mud and rock mixture finally reaches the surface, it cannot just be dumped into the ocean. It gets pumped into massive settling ponds near the shore. The heavy rock pieces sink to the bottom, and the clean clay liquid is skimmed off the top, cleaned, and pumped right back down into the tunnel to be used again. It is a completely closed loop, recycling the same mud over and over to save money and protect the environment. The whole digging process happens in a continuous loop. Push, cut, suck out the mud, build the wall, push again. It is extremely slow, usually moving only a few dozen feet per day, but it is completely non-stop. It operates 24 hours a day, 7 days a week, with workers resting in shifts inside the tunnel. But where exactly is this incredible machine working right now, and what makes this specific location so difficult? The answer is a place called the Pinghai Strait, located in Fujian province on the southeastern coast of China. This specific spot is part of the larger Fuzhou to Xiamen high-speed railway project, a massive new train line designed to connect two of the biggest economic hubs in the entire country. The strait itself is a busy, choppy channel of dark water separating the mainland from a large island. China Railway Construction Corporation, which is one of the largest construction companies on the planet, is leading the charge on this massive project. They started serious design work on this undersea section around 2018, and they began actually digging in early 2021. The total budget for the entire railway line sits at roughly 50 billion yuan, which is about 7 billion American dollars. The undersea portion itself costs a massive chunk of that total budget, mostly because of the custom equipment required to survive the harsh conditions. The tunnel stretches for just over 16 kilometers, but it is not a simple straight shot across the water. It curves gently to avoid the weakest parts of the rock, and it dives down to a depth of 107 meters below sea level at its deepest point. To put that depth in perspective, that is deeper than the height of a 30-story building flipped upside down and shoved into the ocean floor. At that depth, the water pressure is absolutely extreme. If you took a normal military submarine down there, its heavy metal hull would be crushed like a cheap soda can. The concrete tunnel has to be engineered to survive that same crushing force every single day for 100 years. The route of the railway connects the city of Fuzhou in the north, runs down through the coastal towns of Putian and Quanzhou, dives under the sea at the Pinghai Strait, and finally comes up on the other side to connect to Xiamen. By putting the tunnel exactly where they did, they cut the total track length by dozens of kilometers compared to building a bridge or going around the coastline. Every kilometer saved is millions of yuan saved in land purchase and construction costs. The machine doing the heavy lifting was built by China Railway Engineering Equipment Group, a company famous for building the biggest digging machines in the world. It has a massive diameter of over 14 meters. That means the finished concrete tunnel is wide enough to easily fit 2 high-speed train tracks side by side, plus a maintenance walkway, plus emergency escape rooms every few hundred feet. The total weight of this single drilling machine is over 4,000 tons. Moving something that heavy through wet, heavy ground requires an unbelievable amount of power. The giant electric motors pushing it forward generate enough force to push several dozen fully loaded passenger jets at the exact same time. The power cables running to it are as thick as a human torso. Before they could even start the machine, they had to build a giant concrete pit on the shore. They lowered the massive machine into this pit and then started digging straight down into the earth until they went under the sea. It was the only way to get a 4,000-ton machine safely underground without dropping it into the ocean from a crane. To keep the machine fed with concrete pieces, the construction company built a massive temporary factory right on the beach. This factory employed hundreds of workers who did nothing but pour concrete into giant curved steel molds all day long. They baked the concrete with steam to make it harden quickly, creating thousands of perfect puzzle pieces that were then loaded onto barges and shipped out to sea to be lowered down to the machine. Engineers from the China Academy of Railway Sciences monitor every single bolt and sensor on this machine 24 hours a day. They sit in a bright control room on the surface, watching glowing screens. They track the temperature of the motors, the exact pressure of the mud shield, and the tiny millimeter by millimeter movements of the drill head. Nothing is left to guesswork. Yet, even with all this careful monitoring, how do we know the system actually works when the ocean is fighting back? We know it works because they have already done it. Before the main tunnel in the Pinghai Strait was even started, engineers ran a pilot project on a smaller section of the route nearby. They drilled a test tunnel through a similarly difficult patch of seafloor to prove their math was correct. During that test run, the massive machine pushed through over 2,000 meters of rock without stopping once. The concrete tunnel segments they installed during that test had a perfect alignment error of less than 2 millimeters across that entire distance. Think about that for a second. 2 millimeters is about the thickness of 2 pennies stacked on top of each other. Over the length of 20 football fields, the tunnel curved exactly where the computers told it to curve, missing its target by only the width of a coin. On the main project in the Pinghai Strait, the real-world results have been just as impressive. The boring machine successfully passed through a major fault line a few months into the dig. A fault line is a crack in the earth where the rock is broken, weak, and shattered into thousands of pieces like a broken window. Fault lines are the absolute worst nightmare for tunnel builders because water pours through them like a broken fire hydrant. When the machine hit this fault line under the Pinghai Strait, the pressure sensors in the front detected the change instantly. The computer system automatically reacted without a human pressing a button. It thickened the gooey mud shield to push much harder against the incoming water. The machine never stopped moving forward. It sealed the concrete rings behind it fast enough that not a single drop of ocean water entered the finished tunnel. The workers inside said they did not even feel the change in pressure or the danger of the fault line. The computers handled the entire crisis in seconds. After passing the fault line, the drill kept chewing through the rock as if nothing had happened. Today, that section of the tunnel is completely dry and finished. The train tracks are now being laid inside it. But the ultimate test was when the machine finally reached the other side. After months of digging in total darkness, the giant drill head finally broke through the rock wall on the opposite shore. The breakthrough moment was captured on camera by the engineers. You can see the giant spinning drill head slowly poking through the wet rock wall on the other side. As the rock crumbled away, workers on the receiving side cheered and waved bright orange safety flags. The machine had stayed perfectly on target for 16 kilometers underground. The margin of error in the center of the earth was smaller than a few inches, a level of precision that still shocks veteran tunnel builders around the world. Test trains are expected to run through the dark ocean floor at full speed by early 2027. Passengers will sit in comfortable seats, drinking coffee, completely unaware that 100 meters of dark ocean water is sitting right above their heads. But this is not just about one fast train ride. What does a finished tunnel like this actually mean for the rest of the world? When this railway fully opens, it completely rewires the map of southeastern China. Right now, traveling between Fuzhou and Xiamen takes about 2 hours by regular train, and driving a car takes even longer when the coastal traffic is bad. The new high-speed line cuts that travel time down to less than 1 hour. Millions of people will be able to commute between these two massive cities as if they were just neighboring neighborhoods. This creates what economists call a mega region. When people can move that fast, businesses blend together. A factory in one city can ship parts to an assembly plant in the other city in less than an hour. Workers can live in a cheaper town and hold a high-paying job in the bigger city without spending their whole life in a car. The entire economy of the coast speeds up and gets richer. But the real magic is the undersea part of the route. Because the tunnel dives deep under the water, ships in the busy strait do not have to change their routes or slow down. Giant cargo ships carrying thousands of metal shipping containers can sail right over the top of the tunnel at full speed. The trains run silently underneath, and the ships sail loudly above. Neither one gets in the way of the other. This solves a massive traffic jam that has been slowing down the whole region for years. The shipping industry benefits from this just as much as the trains do. The strait where the tunnel is built is one of the busiest shipping lanes in Asia. Thousands of massive cargo ships pass through this exact spot every single month, carrying electronics, clothes, and car parts to the rest of the world. If they had to slow down or navigate around a tricky bridge, it would cost the global shipping industry millions of dollars in wasted fuel and lost time. The tunnel removes that bottleneck completely. Beyond just moving people and goods faster, this project sends a very loud message to the rest of the world about who currently leads in mega engineering. For a long time, countries in Europe and Japan held the crown for building underground train systems. The famous Channel Tunnel between England and France was the absolute gold standard for undersea crossings for decades. It was considered the peak of human engineering. But the Channel Tunnel was built using older, slower methods. It sits under relatively soft clay, and the regular trains inside run much slower than Chinese high-speed trains. By successfully drilling a huge, deep tunnel through hard volcanic rock and running trains at 200 miles per hour through it, China has proven that the old limits no longer apply. They have taken the crown and pushed the technology further than anyone thought possible. Other countries are watching very closely. Nations in Southeast Asia, the Middle East, and even parts of Europe are already talking to Chinese engineering firms about copying this exact method for their own coastlines. If you want to connect two islands, or an island to a mainland, this technology is now the most proven way to do it. The technology is turning into a major export product all by itself, selling the engineering expertise alongside the massive machines. So, if this method is so powerful and proven, why is not every country doing it right this second? The truth is, building an undersea high-speed railway is still incredibly dangerous, and this method has very serious limits that people often ignore when they see the success. First, it costs an unbelievable amount of money. $7 billion for a single railway line is a price tag that only a few countries or massive economies can even consider. For smaller or poorer nations, the cost makes the idea completely impossible, no matter how good the technology is. Second, you need a massive, highly trained workforce to make it happen. Operating a 14-meter tunnel boring machine is not like driving a car or running a normal factory. It requires specialized engineers who understand geology, fluid mechanics, and computer programming all at the same time. China has spent decades training thousands of these experts in specialized universities and on previous smaller projects. A country without that deep talent pool cannot just buy the machine and expect it to work safely. Third, the geology has to be somewhat predictable. If the seafloor is made of certain types of extremely unstable clay, or if there are huge hidden pockets of trapped explosive gas under the rock, the drilling process becomes a total nightmare. In fact, during the planning phase of the Pinghai Strait tunnel, engineers found areas where natural gas was leaking from the ocean floor. Natural gas is highly flammable and can explode easily. If a spark from the giant machine had hit that invisible gas cloud, it could have caused a massive underground explosion that would have killed everyone inside. They had to carefully drill tiny holes ahead of the main machine to vent the gas out of the rock safely before the big machine was allowed to move into those zones. That venting process added months of delays and millions of yuan to the schedule, but it was the only way to keep the workers alive. Finally, if something goes wrong deep underwater, fixing it is a nightmare. A broken drill head cannot just be pulled out easily when you have 100 meters of ocean and heavy rock sitting on top of you. The only way forward is to keep digging blindly, or to send divers down through tiny airlocks to try and fix the broken parts in freezing, high-pressure water. It is a terrifying thought for any engineer. The risks are extremely high, and the margin for error is incredibly small. Even after the tunnel is completely finished and the trains are running, the challenges do not disappear. Salt water is highly corrosive, which means it eats away at metal and concrete over a long period of time. The concrete walls of the tunnel have to be specially treated with strong chemicals to resist the slow, constant chewing of the ocean. If even a tiny crack forms 50 years from now, the water will find it and start pouring in. Maintenance teams will have to inspect every single inch of this 16-kilometer tunnel on a regular basis for the rest of its life. They will have to walk the tracks looking for tiny leaks, check the giant water pumps, and make sure the concrete is still holding strong against the weight of the sea. It is a lifelong commitment to keep the tunnel safe. An undersea railway is never truly finished because the ocean never stops trying to break it. Earthquakes are another major worry for the long-term survival of the tunnel. The southeastern coast of China sits near tectonic plate boundaries, meaning the ground shifts and shakes from time to time. When an earthquake happens on land, buildings shake and sometimes fall down. When an earthquake happens under the ocean, the seafloor itself rips apart and moves. The tunnel has to be built with flexible joints that can absorb the violent shaking without breaking the concrete or letting water rush in. Engineers have designed special rubber seals between the concrete rings for exactly this reason. These seals act like thick rubber gaskets in a car engine, flexing and stretching when the earth moves, then snapping back into place to keep the water out. Testing these rubber seals to make sure they survive a massive earthquake without failing took years of careful lab work before the real digging even began. There is also the simple financial risk of the project. Even if the engineering is perfect, a railway only makes money if people actually buy tickets to ride it. $7 billion is a huge debt to pay off. If the local economy slows down, or if people prefer to fly or drive instead of taking the train, the project could lose money for decades. Mega projects like this are a massive gamble on the future growth of the region, not just a simple construction job. At the end of the day, what China is building in the Pinghai Strait is a masterclass in pushing past old limits. They took a simple idea, like a cookie cutter, scaled it up to the size of a stadium, and used it to carve a safe path for high-speed trains through the bottom of the ocean. If you want to see more stories about how massive machines reshape our world, hitting that like button and turning on notifications will make sure these deep dives always show up on your feed first. If you had $7 billion and a team of the best engineers on Earth, where in the world would you build the next undersea train tunnel, and why?